Hi guys, I'm back with another step-by-step arcade PCB repair. This time on the table is a Donkey Kong PCB made by Nintendo in 1981. I bought this game cheap as untested and probably not working. And I already took a look at the board. Physically it seems to be everything okay, so no missing parts. Looks pretty clean actually. Doesn't look like anyone has done any work to the board before, which is always a good thing. So nothing obvious, no corrosion. So I guess first step after the inspection, as always, let's hook up the board and see what it does. Okay, I hooked the board up to my test setup over here, using this excellent JAMMA adapter which I got from mikesarcade.com. So let's fire it up and see what it does. Oh, okay. Well, I heard a sound when we fired up the board, and we're seeing something on the screen. Well, actually lines of zeros and exclamation marks as it looks. Some flickering going on down here. Okay, so the board is actually sort of starting up and obviously filling the video RAM with something, but well, the game doesn't run obviously, so no reaction to key inputs. Okay, let me just try once more. Okay, same thing, so the program isn't really running. So what we could do now is actually maybe reseat the CPU, reseat the ROMs, put the ROMs in an EEPROM reader, check their contents, if everything is alright with the ROMs. But actually today we're going to try something new. We're going to actually use a new tool I got for arcade repair, which is this one over here. That's a Fluke 9010 microsystem troubleshooter, and this is actually a brilliant device which can be used to troubleshoot processor controlled circuits, and it's ideal to be used with older arcade boards via so-called pods. The troubleshooter is connected to the circuit board through the socket of the microprocessor, and this troubleshooter can actually not only replace the microprocessor and can actually run the game, but can also do a lot of diagnostic tests, which are very helpful if you're looking for faults in the circuits. It can check the address bus and data buses, so can do bus tests, can do ROM tests, RAM tests, I/O tests, and whatnot, all sorts of things. Well, yes, and I'm happy to own a Z80 pod, and the Z80 is actually the processor that's used on the Donkey Kong board. That's this guy over here. So we'll put the Fluke in and start some diagnostic tests. Okay, so I hooked up the Fluke and didn't start it up yet. So this is how the game would actually look without working microprocessor. So there's just garbage on the screen. So if I fire up the Fluke, I can actually run the game by running UUT, run UUT add, that is the start address, so let's just go for 0. Okay, and we get the same thing as before, so this setup is actually working as it seems. Okay, so now let's go for some diagnostic tests. Okay, let us go together through a couple of tests you can do with the Fluke. The first thing to do would always be the bus test. The bus test is actually checking the data bus lines and the address bus lines of the CPU, and the Fluke is actually toggling those lines and is checking if it can vary those lines freely, or if they might be stuck at a high state or at a low state, which might be caused by some device which might be connected to the bus. And it also checks for shorts between the lines. Okay, and to run the test you just have to push the bus test button. It's actually a very quick test. Okay, it says bus test OK. So the address and data bus lines seem to be good. Okay, so the next thing to do would actually be to check if the program ROMs are actually working and can be freely reached by the CPU. The program ROMs in the case of the of the Donkey Kong board are those for ROMs over here, and the CPU can talk to those ROMs through the address and data lines. And each of these 4 EPROMs is assigned a certain address range on the address bus. And I already made myself a little cheat sheet here, which you can see here. The address range for the program ROMs is actually 0000 through 3FFF, and to be more precise, these are actually the 4 ROM chips and their addresses. So it's 0 through 0FFF for one of the EPROMs, and it's 1000 to 1FFF for the next one, and so on and so on. I labeled those EPROMs E, C, B and A, and that's actually how they are labeled on the stickers, and that is according to their position on the board. There's also some labels here, A, B, C, D, E. If you want to check the contents of the ROM with the Fluke will not actually be able to display the whole contents of those ROMs. It will physically be not able, because it doesn't have a display which would support those huge amounts of data, but it will much rather output a so-called signature, which is basically a checksum. So it looks at the, if you tell it to look at a certain address range, it will read all the values from that range and calculate sort of a checksum, the Fluke signature out of the data that it reads from the EPROMs, and will then output the signature. And the next question would be, how do we know if the signature that the Fluke will tell us is correct for the certain EPROM? We know this because on the PC you can download on the web there's actually several programs which can be used to calculate a Fluke signature from a ROM file. And you can actually just look at the Donkey Kong ROMs in your MAME collection, for instance, and using those freely available programs you can calculate the ROM signatures for those files, and that's what I actually already did. So these are the ROM signatures for those EPROMs. So the next step would be to do a ROM check of all those 4 EPROMs and check if the signatures match. Okay, so let's for instance start with ROM E, which would be the address range 0000 through 0FFF, and we would expect a signature of 7C42. So on the Fluke we're going ROM test, and we want to check addresses 0000 through 0FFF, and we are expecting to get a signature which should be 7C42. Okay, so go. So now it's going to read the contents of the ROM, which takes a moment. It's actually going to tell us if it calculated a matching signature. Okay, it says ROM error at 0000 through 0FFF. And what was the problem? Let's press the more button. Signature was EF6D, not 7C42. Okay, so the first EPROM was actually failed the test. So let's just move ahead and test the next one. So that would be 1000 through 1FFF, and we would expect here a signature of 4655. Okay, so we always have to wait a little because it has to check all the 4 kilobytes of data which are on each of the EPROMs. Okay, another ROM failure. Signature was EF6D, not 4655. Okay. EF6D, I thought we actually had this on the last EPROM as well. That is kind of funny. Okay. Let's just go on with the next one. 000. No, excuse me, 2000 2FF, and we would here expect a signature which is 8BD8. Okay, so well, let's see how this test is going. Okay, this one also failed. So signature was EF6D. That is actually again the same number, not 8BD8. Okay, so I'll check the fourth ROM in a second, but well, they all seem to be not giving out the right content, and they actually are showing all the same signature. That's really interesting. Okay, I checked the fourth EPROM with the Fluke and got the same result. So the same signature, and the signature wasn't matching. So I decided to put the EPROMs into my EPROM reader and read their contents, and interestingly, the EPROMs seem to be completely blank. So all the addresses are filled with FFs. There's absolutely no data on the EPROMs, and that goes for all 4 EPROMs, and that also explains why we're having the same signature with all 4 EPROMs, because they're all actually completely blank. So I'm actually now going to try to rewrite those EPROMs which with the content that is supposed to be on them, which I will take out of my main files collection, and I'll put the ROMs back into the sockets, and we'll check again with the Fluke if we are getting good results. Okay, I reprogrammed the first ROM, which is ROM C. That worked pretty well. So now let's get back to the Fluke and check its signature. Okay, we'll do a ROM check. ROM C is 1000 to 1FFF, and again the signature should be 4655. Okay, so hopefully the board can now read successfully the contents of the ROM. So we could just go ahead and replace the other ones as well. Okay, it says okay, so this actually worked. So I'm gonna do the same thing for the other 3 ROMs. Okay, I got all of the ROMs reburned and in place. I'm just gonna try the last ROM I burned, which is the ROM at location E, which should have the signature 7C42. And hopefully this checks out alright as well. And if so, I think we should be ready for yeah, that's okay as well. So let's make run UUT. UUT is actually unit under test, by the way. Run UUT at location 0. And haha, okay, looks good. Okay, there are some graphical glitches, I guess. The barrels look a bit funny. Donkey Kong looks a bit funny. There's some red dots here. Okay, so some minor graphical problems. Let's coin up the game. Okay, that works. So no sound actually, at least no music. Okay, okay, there's some digital sounds. Okay, but the game is running. Oh, actually the walking sound is there. And the jumping sound also. Okay, but that's looking good actually. Okay, so probably now that we saw that the program ROMs were completely blank, I will actually check the other ROMs on the top side of the PCB, which are I think for the music. Yeah, well, let's, oh, they got me there. So maybe we'll check those other 2 ROMs and we might even get the sound back. Okay, I put the sound ROMs back into the board after I reprogrammed them. Now let's see if we get any. Okay, we didn't get that sound before, I think. Great, so we have the music and the Donkey Kong sound. Great, so I guess Concerning the graphical glitches, all the graphic ROMs of course are also suspect, so I'll just continue checking the ROMs. Okay, so I reprogrammed the 6 ROMs that are on the back PCB, on the video PCB. They were all partially faulty. They were not completely erased like the ones on the CPU PCB. But after restoring them, the graphics actually look nice again. So no more graphical glitches. Sound is working, game is running absolutely fine. So no difficult repair this time, just reprogramming the EPROMs. But that's just realistic and how it goes. Luckily, you don't have to go deep into the schematics and use logic analyzers and whatnot for every repair. At least I could show you the Fluke 9010 in action, at least a little bit. If you're asking yourself how it can be possible that all the ROMs on this Donkey Kong board actually failed, the reason for that is probably that for some reason, I don't know why, Nintendo didn't actually protect their EPROMs on certain games with those stickers that you actually find on the EPROMs now, which cover the little glass window. Because through this glass window the EPROMs can be erased using UV light, and over time, just from sunlight, the EPROMs will actually get erased, like we saw with this board, if the glass isn't covered up with a sticker. So probably the stickers that are on this board, normally you find Donkey Kong boards without any stickers, so the stickers on this board will probably have been put on a little bit late when the EPROMs already have been erased. Okay, so thank you very much for watching. If you have any questions, please feel free to leave them at the bottom of this video. Also check out my other videos on arcade repairs, and if you like them, you're very welcome to join my channel. Thank you very much.